Hello everyone, today in this video we'll be discussing the module 2 of data mining and warehousing, where we'll be discussing the important and the super important questions. So this PDF can be found in the link given in the description called as 6M PDFs, and in that link there is a folder called as super important. Okay, so this PDF can be found there, and the notes can be found in the same link. There is a folder called as 18CS641, which is nothing but the subject code. Inside that subject code there is a file in which all the 5 handwritten module notes are there. Okay, so that is the file which I will be referring. Okay, so let's get started. The first question is the efficient data cube computation. Here some sub concepts are also there which are important, so let's have a look at that. So what is the data cube computation, and why do we need a data cube computation? Because in the real world there is a large scale of data, and the data has to be viewed from different perspectives and angles, right? So if we view from different perspective and angle, we'll get different summarizations of the data. So the different summarizations of the data need to be computed for the taking the decisions and the analysis of in the real life situations. So that's why we will be using the data cube computation. So the first thing is how we will be using the computation, like on what is the criteria or the main criteria. Okay, so firstly we'll have to consider what are the things we will be considering, or what are the dimensions we will be going to considering. For example, like all electronics is a data warehouse. In that there are 4 things: city, item, year, and sales in dollar. Okay, so which are the things, if we consider, that will be the most means it will give us the best results. Okay, like for example, if I choose city and item and see which is the best city and which is the best item getting sold, can I get more relevant information for the current scenario? That's what we will be going to consider. Okay, okay, so here are some other groupings given, like city, item, or just by city, or just by item, and so on. Okay, so if we combine all the means write all the combinations, there will be totally 8 combinations for the 3 items. Okay, and those can be represented in the form of cube as well. So if they ask in the exam, you have to write these things. The first thing what you have to write is why we need the efficient data cube computation, and what are the different factors we'll be considering for data cube computation. And third point what you'll be writing is what are the different computations possible for a sample given data. Use the same example, it's already there. The diagram is also there. If you take some other example, you have to means write this from your own and make this from your own. Okay, so it's better to use this same example. And after that, when you write, this is the called as apex, this is called as the base. 1 is getting considered, 2 is means 0 considered, 1 considered, 2 considered, and all considered, which is 3. Okay, so this many points you have to write for the data cube computation. And as you can see, the apex is also called as the 0D, because there is nothing getting actually considered, all is generalized. Okay, 0D means nothing is getting specifically considered, all is generalized. So apex is also called the most generalized, and the base is called the least generalized. This is another important concept, which is the curse of dimensionality. What does it say is that the more computations you do, the more storage space is required, but the more computation you already do and keep, the faster the retrieval will be, right? If you have the SQL queries here, for example, there is a database here. If you want to retrieve the first 5 books which is available in the industry, so if you have already calculated and kept that, you will be easily able to retrieve that within 1 second. But if you have not calculated, you need to calculate then retrieve. But the disadvantage and the advantage is that the more things you calculate and keep, the more storage space it will be required. The less things you calculate and keep, the slower the retrieval will be. Okay, so that's the important concept which is mentioned here. So there are 3 types of things which you can do. The materialization. Okay, materialization means choosing. Materialization means what? Choosing. So 3 types: no materialization, full materialization, and partial materialization. No materialization means you will not compute anything. Whenever the query comes, then you will compute. It is very hard for the large database, because every time you will compute, it will take a lot of time. Full materialization means you will compute everything and keep. It will take a very large amount of space for large database, and that will be disadvantages in the space matters. So what is partial materialization means? You will only choose those which are relevant. Most relevant one you will choose, so it will be less space also, it will be fast retrieval also, and it will be most relevant ones. That's the best method which we'll be using, partial materialization. Okay, so here's some more information as there, you can go through it. Okay, so that's what the materialization. Okay, so 3 things were there: compute cube operator, curse of dimensionality, and partial materialization with suitable examples. Their examples were given, you can go with it, or else you can write the examples from your own as well. Okay, like for materialization, you can give an example of Amazon itself. Like if Amazon calculates all the transaction answers and keeps, it will cost a lot of space. If it doesn't do anything, many millions of users will request something, it will take a lot of time. So whatever the current trend in the market is going on, that only the Amazon will calculate and keep. So based on that, the users will also request, you will get the data fastly, the most relevant data, and it will be having less storage space also, because you're just keeping the important ones, right? So these are one of the example you can give if you don't get any example in the exam. Okay, the next is the two types of indexing: bitmap indexing and join indexing. So if I give you a brief overview of what is bitmap and what is join indexing, by the name itself you can understand bitmap will use what? Bitmap. Okay, indexing means what? You'll be having a document where you'll be referring which page number has what. That is known as indexing, right? So what is bitmap and what is join indexing? In bitmap indexing, I'll show you one diagram. See here, by this diagram easily you can give the example and explain the theory as well. So here's an example which is RID and item and city. R means some resource. Okay, so resource 1, resource 2, resource 3 and all. Item is in H and the city is V. Item is C, city is V. Like that, different cities and these values are given. Okay, now if I have to represent it in this format, what I will do, I'll write HCPS. So R1 is what? H, right? So only H will be 1, rest will be 0. R2 is what? C only, right? So C only be 1, rest will be 0. Like that, representation of this format is known as bitmap representation. Okay, nothing more, nothing less. This much only is sufficient. If you understand this, you can easily write the top and the bottom theory which is mentioned here. Next one is the index means join indexing. In join indexing, just one example I'll tell you. See, if you don't believe that I'm just telling this many small things, is it able to write? I myself remember these small things only and go for exam. Okay, there you have to expand it and write in your own words. That skill you need to have. It's very hard to remember all the things and go through it. It takes a lot of time. Okay, so remember just the key point and just expand it in your own words. Believe me, you will get marks. I'm telling this by my experience. I've tried and tested. You will get marks. Okay, don't worry. Just keep the important concepts in your mind, and then the important figures you have to make. Just and the theory you have to just fill the content. Okay, that's all. But to fill the content also, you can't write just rubbish stuffs. But you need to at least go through this PDF once. Okay, I have gone through it at least once, so I know what are the points mentioned therein. Okay, don't try to memorize the concepts. Just go through it once. Whatever you can get, it is good. Whatever you can't get, it's okay, no problem. Okay. So let's continue. This example is given here for the sales and the location and the item. So what happens is, in the main street you buy a TV which is T57 and that is a Sony TV. Okay, so you have two tables here. How many tables you have? Two tables here. The first table will store the location and the sales key. Okay, different locations, what are the different sales key happened, and the second table will store the item and the sales key. Okay, as you can see, there is item and the sales key, right? So if I tell you to join these two tables, what is the one thing which will come in common? This is the one thing which will come in common, right? Because that's what is common in between these two, T57, Sony TV and Main Street. This type of indexing is called as join indexing. You will get the final value by joining two indexes. That is called as join indexing. Okay, just remember this table and this one, this diagram, and write the theory in your own words. Easily you can write. Sit peacefully and write it. Easily you can get it. Okay, but make sure you go through the whole PDF at least once. Okay, let's move on to the next question. Efficient processing of OLAP queries. Okay, let's see what is efficient processing of OLAP queries. So okay, efficient processing of OLAP queries means what are the parameters we will consider for the efficient processing, means the best processing of OLAP queries. Firstly, determine which operation should be performed. Like in the max and all, if a person buys 12 mangoes and each mango costs 70 rupees. Okay, so 12 mangoes will cost how much? Which is the best operation you will perform? Will you perform addition or multiplication? Multiplication, right? Like that only will choose which is the best operation to be performed on the available cuboid. And after we have chosen the which method we are going to apply, which is the cuboid we should apply, means as I told you before, right? We will select city or item or only city or any other ones. Which is the best one? If we apply the operation on, we'll get the results faster. These are the two things we'll consider: which operation and on what you are performing. Which operation and on what you are performing. These are the two things you'll consider for efficient OLAP query processing. Okay, so here some examples are given, you can go through it. Okay, the next one is this one, OLAP architecture. This is a very important question. ROLAP, MOLAP and HOLAP. Okay, so what are the differences between each of these? Just remember one keyword, the full form of it. ROLAP means relational OLAP operation, and multi-dimensional OLAP operation, and the last one is just the combination of these two. Fine. So what is relational OLAP operation? OLAP is the online analytical processing. Relational online analytical processing means you will have the query transactions. See, if you see here, you will be having the query transactions that is a traditional operations which will be performing, and it will be performed on the relational databases. And the important advantage is that it can handle large amount of data. Okay, and it will be slow. That's the disadvantage. That is relational. And multidimensional means it cannot handle large amount of data because there will be a large spaces available, and there will be no relational database as well. So to store where you will store, that's the disadvantage. Okay, so only small amount of data will be calculated, and the advantage is that the model provides excellent query performance. Very nice. The answers you will get, it will be very accurate. That is the advantage of multidimensional OLAP. And this relational OLAP, the combination of these two is nothing but hybrid OLAP. And if you want, you can give example. The Microsoft SQL Server 2000 supports the hybrid OLAP server. Okay. Moving on, we have the super important question, definition of data mining and KDD. Okay, knowledge data discovery. Let's have a look at that. Don't miss this question at any cost. Okay. So what is data mining? It is a technology that blends the traditional data analysis method, okay, traditional analysis method with sophisticated algorithm for processing large amount of data. Traditional data method plus algorithm for processing large amount of data. That's the definition you have to write for data mining. Okay. Then we have the data mining and knowledge discovery. Knowledge discovery means, see, when you are in a hill and there is a diamond mine there, what you will be doing, you will be mining the hill, and at that place you will get the diamonds, right? So what you are doing, diamond mining and diamond discovery. But here the data is getting mined, and whatever the relevant data will get, if you combine the relevant data, you will obviously get the knowledge, right? So that's what the knowledge discovery is. There are few processes here: data pre-processing, data mining, post-processing. So some data you will get, and you will perform some operations on it, that will be discussing in detail in the upcoming topics. It's very important. Those 7 features are there. And then we have the data mining, which is the main process. Then after that, the post-processing means putting the icing on cake, like that things will be there. No, like that we are doing here also. Okay, so if they ask about the KDD, you have to make this diagram and write what it is, what are each of these process, as well as information regarding the theory, I mean the definition of data mining. Okay. And after this, there are some challenges and scalability. This is the second question, I guess. So let's have a look. Challenges or motivating challenges of data mining. So what are some features of data mining and what are some challenges? So scalability, it's not easy to scale a large amount of data. High dimensionality, there are many features in it. Heterogeneous data means it's taking data from different data sources, and complex data means that it is not means in a format like understandable format. Many things are many factors are getting considered in a single data. Data ownership, see, this I will explain what it is. Data ownership means, suppose that this is the data database A and this is the database B. Okay, now B has to perform some operations, and in that operation a slight amount of data A is required. Okay, so B, what it will do, it will see what is the analysis and the trends of the data A happened here. That is obviously visible, right? That is nothing to be hidden. What are the trends happening in the market regarding this domain? That is obviously visible. But the trends and the analysis is carried, that effort is carried out by the database owner A, right? But it's clearly visible in the market because that's his business. It's we cannot hide that business, right? So that is visible here, and B is taking advantage of this one, right? B is taking the information from this one, and based on that, B is making his own product more better. So this is called as data ownership issue. Okay, data ownership and distribution. Distribution means sharing a large amount of data from one place to another place is not easy. It's very risky, as well as security issues also come. Also, it's very hard and costly. Okay, so those were about the challenges, the motivating challenges for the data mining. Then we have the super important question, which is the data mining tasks. What are the different data mining tasks? Just one figure I will tell you, just remember that figure. Okay, it has worked for me in the internals as well as in the other module tests. Okay, just remember this figure, this is sufficient for you. Okay, so in this figure 4 things are there. Divide this figure into 4 things. Forget about this, just divide this figure into 4 things. Predictive modeling, just remember this one, like a tree structure. Anomaly detection, just some points here. Association analysis, milk and diaper example. Okay, and here we have the cluster analysis. different clusters are there and points are there. Repeat with me. Here what you can see, tree is nothing but predictive modeling. Here you can see some dots. What is dots? Anomaly detection. Anomaly detection means the outliers and the normal things. Association analysis, milk and diaper. Association analysis, milk and diaper. And the last one is cluster analysis. Close your eyes and take a screenshot of this. Okay, after you have taken a screenshot, don't open your eyes, just try to recall whatever is there. You can easily be able to recall. Okay, so that will help you during your exam. So there are two types of data mining tasks. Okay, predictive and descriptive. After you memorize that figure, then only come to this. Predictive and descriptive, by the name itself you can understand. Predictive means you are just predicting based on what are the things you have. Like if it is very cold outside, there might come rain, like that. The predictive task is. Okay, descriptive means you will be using the proven information to form some descriptive analysis of the results. Okay, so some examples are given here. Usually from the available data set helpful in predicting the unknown or the future values of another data set of interest. Okay, for example, if you have the prices of the house present here, and if you build a new house in the some particular area, based on the given information you can predict at least what the value could be, right, of this house. And another example is diagnosing a disease based on the medical test results of a patient can be considered as predictive data mining task. Some results you got, based on that you are predicting what the actual value could be. That is known as predictive data mining task. In descriptive, there are four things. There will be detailed information. There will be what? Detailed information, and that detailed algorithms will also be there for the available data set. That is descriptive. Detailed and predictive means just approximate. Okay, so these things, after you have made this diagram, means describe each of these. Okay, describe each of these means what is predictive. It is like a form of a tree, right? So it's getting continuously divided, right? So it is a process that uses data mining and probability to forecast the outcomes. There are two types of predictive modeling: classification and regression, for discrete and continuous values. Discrete means like these values, okay, point-wise values. Continuous means like integration, okay, like these values, continuous values. So classification is used for the discrete values and regression is used for the continuous values. Just remember those two key points. Anomaly detection means what is the outlier. Like for example, if someone has some disease, all the normal things will be like this, something will be like a different one. This is the outlier and this is the anomaly detection. Just remember this one only. Okay, and go through it once. That should be sufficient for you. Then association analysis. What is closely associated, that will be close. What is not closely associated, that will be far. Okay, so that's for the association analysis. Clustering analysis means there will be different clusters formed based on the different domains. Like for example, there is a company A. In that company A, there are machine learning people, there are artificial intelligence, web development, blockchain, and Android development, and SQL. Okay, so different databases, different types of people will be there for different purposes, and they'll be forming clusters because they have some similarity in among them. So those will be forming some cluster. That is known as the cluster analysis. Okay, so that's what you have to explain if they ask about the data mining tasks. Two things are there: predictive, descriptive. In descriptive, four things are there: predictive, and anomaly, and association, and clustering. Okay, so make sure you go through the notes at least once. Fine. Then we have the types of data and data quality. Here we have a few key points regarding types of data and data quality. So what are different types of data? Qualitative and quantitative. By the name itself you can understand qualitative means what is the attribute of it, like the height and the weight, right? Quantitative means numeric value. Numeric value means how much rupees is this particular item. That is the numeric value, that is quantitative. Okay, then we have a few more concepts. These are optional ones, you can go through it. And different types of attributes. So these are the questions also asked, but it's not more repeated, so I'm not going to discuss that here. Anyways, I have discussed this in depth in the theory videos, you can go through it. Data quality, measurement of data noise, and so I think it's not that important regarding what are the things mentioned here. So yeah, that's basically it. If they ask about the different data types, you have to mention the quantitative and qualitative. And if they ask about the data quality, the quality of the data can be measured by the attributes. So different type of attributes are there. I think you can write this one: distinct data, ordered data or ordinal, and interval, multiplication, and this is a general character, this is not required. Types of data set. Okay, I think you have to write about the types of data set. See here, yeah, just explain about the data and the data set. So data sets you have to write for this question. Okay, So what are the different types of data sets? Different types of data sets is record data. Data which is stored in the form of record and indexes is called record data. There will be transaction and data matrix and document matrix. Graph based data, the data stored in the form of a graph is called as graph based data. And here you have the relationship among the objects and the objects that are represented with the help of a graph. Ordered data, there will be data which is ordered in sequential order, or the time series data, or the spatial data. And data quality, yeah, here comes the data quality. I've tried this one. Okay, so what is the data quality? Data mining application focuses on the detection and correction of the data quality measures. Use of algorithms that can tolerate the poor data quality. It means we are using algorithms to improve the data quality. Okay, so detection and correction is often called data cleaning. Data cleaning means what? Detect what is not clean with the data and clean it. That is known as data cleaning. Okay, so some of the errors which can be measured, here also you will get some points, like what are the different types of errors. Noises and artifacts means this is the clean data, this is the unclean data with noise will be removed. And precision, bias and accuracy, how much precision is there, how much bias is there, how much accuracy is there, what are the outliers. Based on that the mean value is getting affected, you can remove the outliers. Mining value, missing values. In missing values there are some algorithms which you can use to fill the missing values. Either you can ignore the row which has missing value, or fill the missing value manually based on your information, or you can use the global constant to fill the missing values. Means wherever missing values they will fill one constant value, or you can use a central tendency, means mean value you can put there, or the most probable value to fill the missing value. Okay, and few more information is given. I think that should be sufficient, whatever I mentioned. To recall, whatever you have to write for the data, if they ask you about the types of data and the data quality, here you have to write qualitative data and quantitative data. After I mentioned that, you have to directly come to the data sets. Okay, in data sets what you can find is the record data and the graph data, and the third one was what, ordered data. Okay, and in data quality you will write the different types of measurement errors that can be there, like the noise, precision, bias and accuracy, and outlier, and the missing values. How to fill the missing values, that you can write here. And after that, if you have doubt, like whatever you have written it's looking less, then I think you can write this one as well. Okay, so inconsistent and the duplicate values. Moving on, we have the data pre-processing, a very important, super important question. So in different in data processing there are totally how many steps? 7 steps are there. At least 4 approaches you will be should be able to explain. Okay, so let's have a look at data pre-processing. Okay, so data pre-processing means before the data goes to data mining. Before the data goes to where? Data mining. Before the data goes to data mining, there will be performing data pre-processing. So these are the 7 steps: aggregation, sampling, dimensionality reduction, feature subset selection, feature creation, discretization and binarization, variable transformation. At least 4 you should be able to remember from this one. So aggregation means what? You are combining the values. That's all. Merging the values. Okay. Sampling means what? You are dividing the values and then looking at the trend. Like for example, there is 10 liters of milk. Okay, 10 liters of milk is there, or 10 liters of sweet is there. Okay, a very sweet, your favorite sweet is there. So in that 10 liters of sweet, you cannot drink the 10 liters of sweet and get to know what is it good or not, right? You will take a subset of it and then you will be tasting it, and based on this subset you will be judging the whole sweet bucket, right? So in that way we are doing the same thing. Sampling means you will be taking a small amount of the whole data, and then you will be checking if the data is correct or not, and based on that you will be judging the whole thing. Okay, so two ways are there. This also you have to write for compulsory. Sampling without replacement, sampling with replacement. Without replacement means once you take some data, you will not replace it, again you will perform the sampling on it. Again you will take some data, and in the next iteration you will not include the data and perform. Sampling with replacement means once you have taken, again you will include this, again you will mix and see, again you will take the data, like that. Okay, sampling you have to mention these 2 key points. Dimensionality reduction means you are reducing the dimensions. Means if there are many dimensions are there, many properties are there, you will remove the irrelevant properties as well as redundant attributes. Okay, so that will reduce the dimensionality. Feature subset selection means which are the most relevant features that you will be selecting. You have to mention 3 points for compulsory in this diagram. 3 points are what? Embedded approaches. Embedded means inbuilt. Filter approaches. Filter approaches means the features which are selected before the data mining algorithm runs. Okay, filtering the approaches means selecting which are actually needed. Wrapper approaches use the target data mining algorithms. Okay, using the target data mining algorithms as a black box to find the best subset. Wrapper approach is used to find the best subset. Filter is used to find the relevant ones. Embedded means inbuilt. occurs naturally as a part of the data mining algorithm. These 3 points you have to mention and draw this diagram. Okay, here what you will do, attributes are there, it will go to search strategy, subset will be formed and evaluation will be done. If it is correct, it will stop, otherwise it will again repeat the same thing. Okay, then selected attributes will be again scrutinized, and then will be the validation procedure. That is about the feature subset selection. So if you can mention at least 4, and if you can mention more, that will be better for you. You can expect more marks. Okay, so what is feature creation? Feature creation means sometimes 2 or more features will together form a feature which will be more better than the individual features. That is called as feature creation. Okay, discretization and binarization. Discretization means your discretization means dividing them into different pieces based on the continuous attributes, and then doing the operations on it. Binarization means you are converting the whole data warehouse to the ones and zeros. Okay, and based on that you will be performing the algorithms. That is discretization and binarization. Attribute transformation means you will be means sometimes the attributes are not applicable on what the data is given, right? For example, if you have a 10 centimeter scale and you are asked to measure the coastline length of India, okay, you cannot measure by using the 10 centimeter scale, right? So what you will be doing is the transformation. Transformation means what? The length you will be measuring how much it is for a part of the coastline, and then you will be integrating it for the whole coastline. Like that, some other transformations you will do, like the time series transformations or the Fourier transform. So I don't know exactly how they work, so I am not able to tell more information regarding that. But that is very much applicable in the real life, wherein the music also, see, the music waves will be there, right? That will be converted to sine and cos functions, and based on that it will be easily stored in the database. It's something like that. Okay, so the main key point is that you will be transforming the data to some different type of data for the easier transformation. That is called as attribute transformation. So these many features you have to compulsorily do before giving to the data mining process, so that it will be very efficient and very fast, and more accurate results will be taken. If you give very bad data to the database, obviously you will get useless results. Okay, so make sure you clean the data and then only give to the database. Finally, we have the topic which is measures of similarity and dissimilarity. Here some numericals are also asked. I will be discussing the numericals in a separate video. Here only I will be discussing the theory. So what do you understand by the term similarity and dissimilarity? Similarity means same, dissimilarity means what? Different, right? That much only is there. Similarity means you will be having same things together, and it will be represented by 1 very similar, 0 no similar. In dissimilarity it's just the reverse. 0 means 2 dissimilar, 1 means 2 not dissimilar. Okay, and there are some measures which you will be using, like proximity measures. The closeness, proximity means closeness. This one of the formula, another formula is here. Okay, so just briefly go through the formulas. I'll tell you what are the important formulas in a separate video, so we'll be discussing that in detail. Similarity and dissimilarity between the simple attributes. Nominal attributes you will measure using this formula. Ordinal attributes, internal or the ratio. And distances you will measure by using the Euclidean distance, or some other types of formulas can be used for measuring the distances. And here we have the data objects. Similarity measures for the binary data, SMC and Jaccard coefficient. So these two also the means the algorithms means the numericals are asked. I will discuss that in a separate video. So that's all for this video. The module 2 was this much, and if you have any doubt, ping me on Instagram. My ID is in the description box. And thank you so much for watching. Hit the like button, subscribe to my channel, and I'll see you in the next video.